Okay, so hello everyone. My name is Cathal Hoare, and along with my co-authors, we'd like to talk to you about a utility-aware knowledge graph to support multi-scale residential energy modelling. And this work is done, I'm kind of based in both places, in the University of Limerick and in UCD, but it's done with a series of colleagues from these two places. I guess being from Ireland, and particularly Limerick being on the west coast, you kind of think that we'd be suffering a little bit in the bad weather, or in the bad heat, we'll say, the beautiful weather that we have here in Corfu. But actually, like most of Western Europe, for the past couple of weeks, Ireland has been experiencing its version of a heat wave, which is reaching astonishingly high temperatures of about 28, 29 degrees Celsius. We're not used to it. If you look at the national broadcaster today, you'll see the headline is the weather. If you look at other media sources, you'll see kind of, those humorous stories about how hot it's getting, the roads are melting and things like this. But the truth is, it is getting warmer and there is a change in the weather. In the past 4 years, Ireland has had its four highest hottest years in those same 4 years, and this year is probably going to exceed that. So we are seeing the effects of climate change, and also then we're having to consider, I suppose, what are the effects of this going to be on our infrastructure, and in our case, particularly considering electricity distribution. In parallel with that, if it's not a headline about the weather, it's usually a headline about the energy crisis, so the cost of energy, our ability to generate enough electricity in the country, because we're using an awful lot of renewables, and how do we manage when there are shortfalls in that. And of course then the demands of having things like a large number of data centers and so forth. And in parallel, then there's a general shortage of housing in the country, residential housing. There's a serious shortfall that's having an economic impact as well as the cost of living grows. I won't say exponentially, that's probably overstating it, but still quite steeply. So these are concerns of the government, and this is, you probably won't be able to read all of the text, nor would you want to, but this is an example of several strategies that the government agencies are publishing. This one is from Sustainable Energy Authority of Ireland, and it's their strategy for the next 5 years or so. And I suppose all of these strategies, they're setting standards for what we need to achieve in order to resolve the issues that we're seeing in the headlines. And they're taking an all-encompassing view that includes societal and economic issues like transport, health, quality of housing, availability of housing, availability of the infrastructure that companies and so forth need to operate properly. And the issue that arises here is each of those different segments is being managed by a different agency in the government, and now historic data silos are becoming an issue as we try to, I suppose, merge these different sources of information so that we're able to create an all-encompassing view of, I suppose, the state of the information that we have that can drive these policies to a successful completion. So today's presentation in the paper, our work as a group, we're supporting policy through data-driven residential energy simulation and prediction. That's what my colleagues are doing. My part of the picture is to look at how we can create a rich knowledge graph that includes all of the information, both population information, building information, energy certificate information, and now electricity distribution information that includes things like capacity, headspace, and so forth. How can we bring that information together so that we can inform those data-driven approaches and then simulate various scenarios in the future and model then what demand will be based on those various scenarios. And I guess what we're trying to do then is achieve this at a national scale, all the way down to individual neighbourhood scales, so kind of multi-scale. So in terms of, I suppose, our data sources, just to give, I suppose, a sense of the numbers of different agencies and companies that we're dealing with, we have everything from ESB networks, which will be the distribution network, GeoDirectory, which maintains a database of every residential property in Ireland, SEAI, who we've mentioned already. Irish words that I won't try to pronounce because I should be able to, but I didn't really pay attention in class. But essentially the Central Statistics Office and Ordnance Survey Ireland, so that's Tailteann, Éireann. And then, of course, our own Energy Institute and UCD, which is producing results that we can also feed into our knowledge graph in order to enable that. Now, in previous iterations of EC3, we've described this core context idea, and basically we use this very simple construct in order to create verticals that define various contexts, and then at various levels we can associate different types of information at those levels. So if we see right over there on the right, we can see at the bottom we've got the building, and we would choose one particular representation of building information, and then we would create associations between the other versions of building information that we would have from the different agencies at that level. Then if we go another level up to small area and so forth, then we're looking at maybe population statistics and so forth. So what we've done to extend that is add the transformer extension, so that creates a representation for each of the transformers in the distribution network. And then we're associating the area that's served by that transformer and also which individual buildings are connected to that transformer. So the process that we follow to achieve that is a four-step process. So again, we've got our entity definition. So again, the information that we have from our information sources to represent both the individual buildings and the transformers. And then creating the relationship and assigning the relationship between individual buildings and the transformers. Now, in this case, we're using a heuristic that ESB Networks itself promotes, which is basically nearest transformer to building. And this is their own policy in terms of how to decide, in most cases, how buildings are associated or are connected to a transformer. After that, we create once we've got each building associated with a particular transformer, then we group those clusters of buildings and their transformer, and we create a convex hull that's defined by the set of points represented by the buildings. That gives us the area that's served by the transformer, and then we insert those two pieces of information, the relationship between the transformer and the individual building, and that served area to the knowledge graph. And the map here, which looks remarkably like a map of Ireland, if you keep zooming in or if you had sufficient resolution, you would say that this is actually created from all of the little areas, the convex hulls that are defined. And that leaves us then with our graph structure. So again, I suppose that idea of the core context, we can see it running down here on the left, going from county, which might be associated with weather information, the small areas, which are associated with the small area population statistics, data sets, and also then geographic information. Then we get to the buildings and the different representations of the buildings. On the far side, we have another context, which is transformer through high voltage, through low voltage, and the whole chain, essentially back to the point where we're at the end of the chain of transformers, and we can associate that with an individual building. And then the area that's being served by a particular transformer as well. And again, they form aggregates depending on what level that they're at. Yeah, so this is the last slide. So here we are. This is, I suppose, just a little view of I suppose once we've created the graph, these are the types of things that we're able to do. So we've got Divyanshu creating us predictive models. So again, simulating various scenarios. What happens in a particular area if there's adoption of, an uptake in EVs, or if there's microgeneration going on from solar or whatever you might have. And then my colleague Sharon on the far side creating these wonderful visualizations, I suppose, that allow policy makers and decision makers in the various agencies to examine their information in the context of the wider knowledge graph that we've created. So that's me.
Thank you very much.